Vast is a puzzle platformer that you play with JavaScript code. I built Vast for the Kajam 2021 huge game jam run by Replit, and it was built in 5 days. I started on Thursday and I finished over the weekend. In this video, I'm going to be talking about the challenges I faced in each level and what I learned about game development and using Kaboom as I was building the game. So you'll watch me play through each level and also do a little bit of coding. Level 1 was basically when I didn't really know what I was building. So let's check it out. Um, I was just getting used to Kaboom and trying to just get something jumping around. So the sprite here is from Itch. It's in my credits actually. So let me go ahead and just look at the credits. Um, Pixel Prototype Player. And it's funny because some other people in the jam made some games, some pretty great games out there, and I was noticing that a lot of people had this sprite in their game. Um, I like how it ended up like working out. I think the player looks like it fits the game, which I'm pretty happy about. But honestly, level one was just me being like, how does Kaboom work? And just trying to get something to jump around and be animated and like jump on these rectangles. So let's take a quick look at the level one code so you can kind of get a sense of like what I was building here. And this is definitely not how it started. You can see that this is like in a level one JavaScript file, but it was definitely just like my only file for a while as I was kind of figuring things out. Kaboom has this construct called an add level, which you pass in a configuration for the level. You say how big is each like cell of the level, which is usually going to be based on your camera scale, and you specify symbols that you can use. So you can see that there's an equal sign and a asterisk symbol. When you use an equal sign, what we will add to the level, what we'll add to the game, is a rectangle of the cell width and cell height, which I think is 32 and 32. Let me check that real quick. This cell stuff comes from my main file, and I globalized it. So the cell width is the width of a screen divided by 20. So whatever that ends up being. And if you use an equal sign, it'll create a rectangle that is like that wide, about like 20 width of the screen. It's solid, which means that any other thing that is solid won't pass through it. And it has an area, which is required if you're going to use the solid component. And then we have the star, and there's actually only one star here. So you can see the equal signs being used and the star being used. And it's a little bit hard to like map the string itself to what it looks like in the level, but you can see that it's like, here's this platform right here. And then here's two stacked like platforms on top of each other, which makes it end up like looking like it's just like a really like vertically fat path platform. And then a little bit more. And then the star is actually our doorway over here. This was literally like, I was like, okay, I have white rectangles. Let me put a red rectangle on the screen. But that ended up being kind of like my spooky door, which is like the goal of every level at this point in the game. And yeah, it's just a red rectangle. So it's a rectangle that is this wide, this high. It has this color 25500 red. Origin top means that it grows like from the top. So if you specify a height rather than it like being in the center or from the bottom, it like grows downwards. And origin is a pretty powerful mechanism, even though it's like kind of simple and a little wonky sometimes. We provided an area so that we can tell when something's there. It's not solid, right? So it's not like it's not going to prevent anything from like moving through it. It's just got like an area, which you can always check with Kaboom if you hit the debug mode. If you hit F1, you can see that like you can see all the areas on the screen, and all of these game objects have areas. They have like collision type stuff, so you can see like the little boxes moving around, and each of these little boxes is one of those equal signs, and this is that asterisk. and it has a tag on it, which is really important, this goal tag. So that brings us over to like kind of where not so much level 1 stuff is happening, but my like base game player stuff is happening here in main.js. And if we look for the string goal in here, we can find this right here. If there is a key press of W or E, so you can actually move through the doors by pressing W instead of E. Kind of like I was thinking of like a Super Mario World where you go through those doors by like looking up. But you can hit E, and that's what most people do. It checks to see when you hit E or W if there's a door on the screen, and if there is a door on the screen, one of these like red rectangles, it checks to see if the player is touching the door, if these boxes are lining up, these areas. So if we like jump across in debug mode, and I hit E over here, right? I'm just gonna slam E for a bit. You can see that nothing happens. But if these things are touching, they're not quite touching yet, but if I, yeah, there you go. And I hit E, it makes me go through the door. Yeah, so there's a whole bunch of like checks for that. I can show you this in level 2 when you go near a computer, but there's a lot of like player logic kind of like isolated here in the main.js that, you know, when you hit certain characters, if you're near a door, if you're near a computer, or if you're in the boss level, sometimes things are happening. And every time you go through a door, it uses the level manager. So I have this like class over here that manages all my levels. I have all these like load level functions. If you look at the actual level files, you can see all they do is export a single function. A function that takes a player and then does everything that the level needs to do to set up. Sets the spawn point of the player, resets the camera or sets the camera scale for that level. And every level kind of like has its own like needs. And then it returns a function that is meant to like clean up the level. So what is on this level that needs to be removed as we move on to the next level, which was kind of a pain point for me for a bit. And we'll see more complicated examples of this in the future levels. That is one thing that I kind of didn't do, was use scenes in Kaboom. I just kind of like made it so that like everything was the same scene, and then I would just like remove objects and then add objects and reposition where my player was instead of using a scene, which was probably not a great idea, because I think the scene stuff in Kaboom lets me do all of this cleanup a little bit more directly. But that's just kind of like how it ended up working out when I was crunching on this game for days and days. So yeah, let's play through level 1. I like level 1 because it's where it started. I did not have the idea of a programming game at all at this point, and it really just kind of teaches the player that they can jump and they need to get to the door, right? It also means that if they like fall down and die, it'll like respawn them. So we can check that out real quick. The way that I register that your player dies, it needs to respawn. It's not really a death, but it's right here. So I check to see, unless the player is phasing, which comes into play like in the later levels, I check to see its Y position on loop. So there's a player action down here, and I check to see if the player is not in a boss fight and the player's Y position is greater than 2000. And the way that the Y position in Kaboom works is that 0 is the top, and as you increase your Y, you go downwards, right? A lot of people are used to like a Cartesian graph where the Y, as you increase it, means that you're going upwards direction. Up is actually like this way, or more Y means you go downwards in a direction. And I say that if your Y position is greater than 2000, which would happen if you were to fall off the level and increase your Y, once that does happen, I call the spawn player function that I have here. And what does spawn player function do again? It sets crouching to true. So you can see that like when you fall, you're in like this crouching state when you reappear. It sets my opacity to 1. There are certain things that like make the player fade out. We move the player to a spawn point, and since we're not providing a speed value, it just kind of like makes it teleport to that spot. And then I wait 0.75 seconds to disable crouching. And crouching is kind of like a mode that the player goes into in which you can't move around, right? So if you're crouching and you try to move around, you just can't. And that gives like that gives like I didn't want to include death or lives or anything like this in this game, but I did want to like make it so that when you do fall off the level, there's like a really tiny punitive thing that happens to you, and that you can't like move right away. There's just like a little flash of like, oh, I'm stuck, or I have to recover, which kind of gives it like a little subtle feel of like, I don't want to fall off unless I have to. All right, so yep, we jump through the level, jump, 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 and we go through our door, and we're on to level 2. Level 2 is where this game actually kind of like became what the idea of this game is, with the programming and the computers. I Level 1 was just on its own. I had no idea what this game was going to end up being. I was happy to have something jumping around, landing on platforms. And something that I noticed when I was going through the Kaboom documentation is that you could create text objects instead of like rectangles or a sprite or something like that. Here is this text object here. Here's a text object. I'm using the add function from Kaboom. I'm saying here's the position of the text object. Here is its text, which right now is set to hello world, but I could like make it something like banana. And I pass it into text, and it has a font style or a specific font, and then also its size. And then you can take the text object and give it an area and solid. And I thought that was kind of cool because like you could jump on top of the text objects, which we can see here, right? So if I go and load level 2, which I turned the text into banana, like you can actually like run on top of it. And I was thinking like, oh, cool. Could I build a game that like tells a story and you're like jumping on top of the text that is the story, um and like controlling a player, like platforming across like a novel or like someone speaking, and then like the text shows up as they're speaking. And that's kind of like where I started, and then I was thinking, wouldn't it be cool if the player themselves could pick what text they're running on top of? And I was wondering, since I am a programming instructor, if I could make this a game that you could learn or at least use what you've learned about JavaScript to play it. And that's when like I've solidified the idea. I'm like, oh, okay. I was really inspired by a couple games that I want to show to you. One is called One Dreamer Prologue. This is a game that you can get on Steam, and it's extremely artful. I think it's really really great. But this is like a story based game in which there are objects all across the story that you like interact with and like change the code for, which is, if you've played my game, pretty similar to what I'm doing. So definitely like heavy inspiration from this one. There's another game too called Quadrilateral Cowboy. And neither of these games like make you write JavaScript specifically. They have their own kind of like pseudo language. I think One Dreamer Prologue is actually based on like C sharp, for like Unity knowers. But this is another game in which like you're doing puzzle solving and you like write some code or like interact with like terminals. Although it gets a little bit more, it's not so much just code, but also like more generic puzzles. And I was like, that seems cool. Like I really want to build a game where you program within it and you control the world around you with code. So that's where this little pewter up here comes in. So let's go ahead and jump to it and use it. And the idea of this level is that what you have here at first, let's turn it back to Hello World, since that's how the game actually introduces this level. Hello World is here, and you can land on top of it, and then you can try to jump to the door, but I don't like. I've tried to time this really really closely, and I don't think you can get there. Like you need a little bit more to this text in order to get there. You also can't jump to the door from here. Like you definitely can't. Let's see. Nope, you can't get there. So the idea is that you need to change. You need to change this level that you're in. You need to change your environment. And you do that with these computers. And you hit E, and then you like crouch down and start using this computer. And I would say there are 3 levels that I spent the most time building. Level 7, level 8, which is the boss level, and then level 2. This level 2 is when I got this like idea of a computer set up and this like text editor here. So a couple of things to note about this text area, and the way that you code in this game is that there are lines that you can't edit. I make it so that you like the idea, I guess, is like you found the computer and you can change a little bit to it, but some things are out of your control. Like if you're hacking into the computer, you can only change like certain like lines of it, which is pretty which once again is kind of like an inspiration I got from One Dreamer Prologue, in that like you have constraints. And in this case, you have a function called make platform that is going to get called with whatever the platform message is. And you can update this, right? You can say hello world, hello, hello. And then that like changes the actual text in the game. You can also go back and change it again. You hit enter in order to do that. You can break this as well. So if we put it in a syntax error like that, I actually am catching whatever error might be thrown by the code you're writing and like make the screen shake and like a prrr happen, and put your error text there. So if I like said this, change the variable name, put it in a string, it's like platform message is not defined. And it's like a close enough science. So let me show you how I'm doing this, and all the things that kind of like have to be put in play. So in my code, there's this computer file. This computer file, or pewtersindex.js, is what I have. It's exporting a function called buildPewter. And this is how I create the different kinds of computers that are in the game. They're all specifically sprite objects, but they are tagged with computer. And when the player interacts with the computer, when they press E, so let's go ahead and check for like the E press in this file where the most of the player logic is. If they press E and they're near a computer and they're not currently computing, we will trigger that the player should be computing. And when the player is computing, it crouches so that you can't move around, right? So it's like kind of stuck here. It does some other things too, where it like focuses on the code editor and stuff like that. And yeah, the actual thing that they code inside of is not part of the game. I think that's probably one of the most complicated things that I had to do. It also means that I can't play this game in full screen, unfortunately, because these little code editors, if we inspect, are DOM elements. They're not actually drawn into the canvas of the game. Here's the canvas of the game that's rendering the player, it's rendering the text, it's rendering the platforms and everything in the game. But anytime you're using the actual code editor, it's actually a DOM element or HTML element that is being positioned on top of the game canvas and kind of like relating to the position. And there's a couple of things that I kept in mind where like if you're resizing the window, it'll kind of like retrack or reposition itself. And I'm using a syntax highlighting library called highlight.js, which made it so that I had to do a whole bunch of kind of fancy stuff. So I'm not going to get too deep into this because I could talk about it for a really long time. But there is this one file in here called editor utils in the misc directory. And this is the reason why I have to spend so much time on level 2. I would say if I started this game on Thursday, I spent most of Friday working on the code editor. Because what's happening is as you're typing, let's go ahead and see the DOM element that changes. You have this content editable true element, and it's constantly being kind of like re-rendered with whatever the syntax highlighting should be for this like block of code. And that was really hard to do because the thing is when you reattach all the content into this editor, your caret position, because it's new content, would go back to the front or go back to the end. I forget which one it is. So I had to do a lot of like I would say like fancier sort of like DOM selection, DOM manipulation type stuff with these things called selections and ranges, which is built into the browser in order to track where the user's cursor was, what they may have selected, so that as they're typing or as they like enter a new line, I can do my best to make it sure that their caret ends up in the right position. And this is like, so you can see different functions in here like get caret position. Where is their caret, the little cursor that they type with now? Recreate caret position. So once new syntax highlighted text goes into this editor, where do I move the caret position to based on what it was? How do I recreate their caret position? And there's just like a whole lot of things happening in this file to make the editing experience feel nice. And here is the actual usage of the computer. So we build a computer, and I have a get code block function, which basically says here's the content of the editor itself. Any line that I pass in that's not in an array is a static line. So you can see this like hello comment. You can't edit it, right? You get the like little like no smoking sign type symbol on top of it. You can't change it. But then anything that gets passed in this system that I created with an array, this is like an editable line. When someone hits enter, it calls this on execute, and I'm taking the code that you type as a player and sandwiching it usually in between executable code that I've defined. And a lot of these things are just like I precursor them with this name Abel, because that's the boss's name. I'm not sure why I called him Abel, but that's his name. And uh, it takes the code you write in your like editable section and activates it and like runs it with eval, and then whatever gets passed in affects the game. So that text object from before, right? We have this text object here, which has an initial bit of text. When you write your code and you set platform message, it calls make platform, which technically is this like window function that is able to be accessed by eval, and then passes the name in and then sets the text to that. And this is like the most simple sort of way that this works in the game, but it has this sort of effect where the text object in the game exists here, and then when you update your code here, I eval your code, and it updates the actual text object in the game to be a little bit longer, and then you can jump across it. Something I also want to do in this video is kind of show you some interesting ways, now that we're like in the computer levels, some interesting ways in which you can solve these levels, or like ways to break them. Something that I thought was interesting is you could, instead of writing text here, just put in a bunch of spaces. And then it doesn't look like anything is actually there, but now you have like an invisible platform that you can like run across, because it's just a bunch of space characters. So it's kind of like, you know, just like floating on air. If you were to make the text really, really long, then you can't get underneath, because the spaces in the actual text are in fact like not gaps, but part of the platform. But yeah, we can see how long that is by looking at the debug mode and its area for that solid. And yeah, and that's level 2. So level 3, the way I worked on this game is I did it level by level. The way that you play the game is the way that I built the game. I started at level 1, and then each level was built sequentially until you beat the game. In fact, the ending was the last thing I worked on. So level 3 followed level 2. And level 2 was the first time that I implemented the computer idea of like you being able to program the level. And then I was like, okay, well, it's a platformer, right? You're supposed to be jumping on things. So the next logical step is let's use some code to control these platforms. This level, the layout is inspired by, you know, when you get to the end of the second level of Super Mario, like the original one on NES, the dungeon level with the there's the before the warp pipe. There's the like three platforms that are like the on the rails that go up near the end. That's kind of like I was like, okay, I want to like set up a level like that. But the idea here is that two of these platforms you cannot jump across. There's no way. Like I tried for a while to see if like somehow I was able to in this game system do that. But no, if you jump on these platforms, you get whisked right up, and then you end up above y -5, which is where I respawn you. So the idea is that you got to slow these down. And the computer that you do that with is down here. So this is actually an update that I made here where it starts with a little bit of code because I got some feedback that it was kind of hard to figure out if you weren't like very used to JavaScript programming, how you would actually change the platforms. So here is one platform that has its speed set. And then you can say, I want to affect this second platform, which in the array would be index 1, and I can set its speed to like, let's say 275. And it makes the platform go much slower. And then you can do the same thing. Putting line breaks in this text editor, by the way, took a long time. The text editor was a crazy amount of tweaking, and I never got it perfect either. There are definitely things you can break with the text editor. But yeah, you jump across and then you can beat the level. And that's the idea of this one. There are two things that kind of got introduced in the game as a result of this level. Let's restart it and take a look. So first of all, the reset computers. So the reset computers is something that you never have to use to solve any puzzles. I thought about building a level where you have to reset your code in order to like fix the level or like get through the level. And no levels require you to use it, but there are certain ways that you can get stuck in these levels. So let's say that you go down here and you say platforms index 0 speed is like really fast. Now you have no platforms you can jump across. And if you happen to do that and then fall, in order to get back to the computer, it's just not possible, right? Like you can try to like squeeze through right here and like get there, but you just can't. And you could the second thing I want to talk about is why this platform is stopping, by the way. But yeah, you just can't get there. So I needed a way for you to reset the level without having to reload the game, which would be annoying. So that's what these blue computers are for. They reset all code computers. You use those, and then the code that is written on any computers in the level gets reset back to what it originally was. And if we look at the computer code for this level, so let's look at level 3, you can see that, let's look on execute. When you execute the code, I take these railed plats. These are actual like rectangles that I have in the game that are like moving upwards at some speed. And I make it so that I loop through the objects that you said and like how you've changed them and changed the speed of these things. So here's my railed plats right here. They are rectangles. They have solid area. They have a Z2 so that they're on top of those like vertical lines that they seem to be like kind of connected to, although they are technically separate. And they have a custom like speed thing. And then there's an action registered, which I realized that I should probably like put it on the plat action instead. But it makes it move based on that speed. So when you execute, write your code and like execute, it will make it based on this speed in the action loop, in the update loop. And yeah, that's the idea of these plats. Now, the other thing that I noticed when working with Kaboom is that it doesn't like deal really well with moving platforms. So let me see if I can recreate this issue that I had to solve here. Let's take a look at this code. When the player is touching a platform, I'm doing, yeah, right here. So what's happening is if the player's current platform, this is something built into Kaboom that tells you what an object might be on top of if it has a body. So this comes from the body component, and whatever it's on top of is the current platform. And without, let's see what happens if I get rid of this, and we reload the game and we go on that platform. Yeah, you see that? You see how like when the player's on top of the platform's trying to move upwards, but the player themselves is solid. So it's two solid bodies kind of colliding, and the platform just stays still. And this was really not great for the level because like the point is that like you need to be moving upwards with the platform. So this little bit of code, we read through it together. If the player is currently on a moving platform, what I do is I make it so that as if the speed is above a certain level, like those really fast ones, I make it so that the player can't jump at all. In fact, if they jump, it makes them go downwards because what was happening is that like it would like do this like weird bounce on top of the weird platform, like on the fast moving platform, and might actually like end up like getting across. So I had to kind of like change the way that the player object functioned as far as its jump ability if the platform is moving really fast. Um, and the other thing I'm doing is I'm making the player move upwards with the platform artificially. This line right here, line 156, if the player is on top of a moving platform that's moving upwards, I make the player actually like move upwards with the platform as if like following it. Because if I don't do this, this is what happens. I get like it's just like it's two solid bodies preventing each other from moving. So if I put this code back in, the player at this point, like standing on the platform, is actually being moved up, and it makes it so that those solid body connections do not conflict with each other anymore. Which took me a while to kind of figure out. So just to demonstrate how this might look when it's like broken, but an exaggerated use case. That's interesting. It's just like, yeah, let's do sorry, like negative 100. It's just kind of like shoot upwards. Yeah, it changes it a little bit, but it's just oh, I'm sorry, that's the speed. That's the speed. So maybe we want to do like a different vector. Yeah, there's something happening here where it's like it's moving up quickly, but then also getting caught by the platform. But yeah, it was a tough problem to solve, and more kind of like player motion comes into play in like later levels as well. And this was like my first encounter with it. But let's beat the level. Something that something that can totally be done that I didn't see a lot of people like doing when I've like watched them play is they would set the speed of the second platform and the third platform, but you can just do a loop here. Like you can loop through the array with like a for each, and then set each plat speed to something. So let's set them all to, I think 200 is a nice speed, right? And that just like changes all the platforms at once rather than doing index 1, index 2. And now we can jump across and get through level 4. Level 4 is the first usage of what I call the gravity strip. Is this like little flashing rectangle here. And as your player enters it, it loses some of its velocity going downwards and like gets affected by like new gravity. So as long as you're in this zone, you should have a different gravity. And the way that you beat this level, there's a couple ways to do it, but you have this code block here where you can say, well, the gravity's 1, and then if you're in the blue zone, so if you're blue zoned, you get to reset the gravity value. And you can see right now it is 1.5, which is necessary to get to this platform, right? Like if we had a gravity 1 set here, and then we got to this zone, it's just like you just fall right through, um, and you'll never get to this platform. So if you made that mistake, you reset your code, and then you go here, and then you can set your gravity to 0 or a really small number or even a negative number, as long as the negative number is also pretty small. And that will make it so that, first of all, you have to die or like fall down to get back up, which I did on purpose. I thought that was an interesting like mini puzzle. Um, and then you can like kind of float across, and you can see that the player even has its like own like new animation as it's like in the gravity zones where it's like kind of like soaring. Um, I ended up not using as many animations in the sprite sheet as I could, but here's where I got like the ability to do one. And then you can float across, and there you go. So actually implementing this like gravity system in the strip was really hard. Because when I started, when I had the idea for this level, it's like, oh, when you're like, they're in these zones, they'll have different gravity. Maybe they'll like thrust this way or like move this way in this direction. I started to realize that the body component in Kaboom and the physics that are applied to the body component, which the player has, is extremely simple. In that, for example, if you affect the player weight, or if you affect the player like the gravity around the player, even like the velocity still maintains. So if your player is falling through the world and then you suddenly make its weight 0, whatever velocity it had from the gravity and it falling before will still apply and have to like degrade before it stops. So setting weight 0 or setting gravity 0 doesn't actually stop the player from moving. Um, which was a hard thing to get around. So this is like one of my biggest workarounds I had to employ, um, having to do with the body component. And let's see where I do it here. Max velocity is what I'm looking for. Yes. So the body options that you pass in when you use the body component, let's go and look at that where I'm creating my player right here. So this body, and then I pass in a body config, which looks like this: weight, jump force, and max velocity. I read through the code for the physics of Kaboom, and the amount of like falling speed that is being applied to an object with a body component is only ever constrained on this thing called max velocity. But there is no direct way to change this max velocity on the object that has the body component. However, if you maintain a reference to your body options that you pass in to create the body component, which you can see that I have this object here, line 46. I pass it into the body component here on line 62, but then I'm also including it as a property directly on the player object. If you can mutate what the max velocity is, you can stop the player from falling, which is what I ended up doing here in level 4. I say if the player is touching the gravity zone, I adjust its max velocity to be different, and that kind of like makes it so that I can actually like change how fast it's falling. And I put in this like degrading sort of like functionality where it starts with an adjusted velocity based on how the gravity's changing, based on what the code is written in that computer, and like a little bit of padding with the 50, so that when you hit the zone, you kind of like slowly like a little bit of friction, right? So if we set the gravity to 0 and then fall through, there's a little bit of like, there's a tiny bit of like friction that happens when you hit that strip. In that like you don't just stop moving as soon as you hit the strip. There's a little bit of like remaining velocity that lets you kind of like and then like end up floating, which is the kind of thing I was going for. So if you have this sort of problem in your own game with Kaboom, where you want like an object that has been falling to completely stop, but setting the weight and setting the gravity isn't enough to do that, I would recommend when you create your body component, holding a reference to your body options that include the max velocity, and then you can change the property on that object. It's not great. It could end up being like, it's one of those problems where you have a mutable referenceable object that is now being like having properties change across many files, and that's the kind of thing that can create bugs really easily, but it's the only thing that I could figure out in order to get this kind of thing to work. So that was the big lesson from this level. One interesting way that I like to solve this level is to make a negative gravity, and remember it has to be kind of like a small number, so like negative 0.2 I think works, and that makes it so that like you're getting negative gravity, which like bounces you out of the strip, which then sets your weight and your gravity back to 1, which then you fall back into the strip, and then you just have this like little effect of like bouncing across the strip, and then completing the level. By the time I got to level 5, I had to start thinking about how was I going to fit the theme of this game jam. So this was built for a game jam that had a theme huge, and there was nothing huge about my game. So I had to kind of like start thinking along those lines of like, what am I going to do to match this theme? And I knew I needed to make like, now that a player has played through 4 levels of this game and gotten the basics and like did a couple like written a couple solutions to what you need to do, I wanted to like expand it a little bit. So I had this idea of building a much larger level, which ended up being this here, level 5. It I'm not sure exactly how I don't remember how I started with the idea of this level. I think I just like took one of the level map strings and I just like looped through and like made a huge grid. And then I was thinking like, what if in this huge grid you just had like little platforms that would like change their opacity, change like how transparent they are, and do it in like a random fashion, as if like um I always imagine kind of like those like maybe like a trading floor, or like one of those like old phone systems, and it's like a bunch of blips everywhere. So you're kind of like in this like calculating entity of some sort. Um so that's what this level became. The idea with this level is that you cannot drop through anything that's like white and like solid, but if it's gray like this, you can drop through. And right now, everything is like moving a little too fast, and you can like try to drop through, and it is possible if you get lucky. Like you can run back and forth and get to a point where you can drop through, but it's really, really hard because things are changing too fast. But you can see the computers here, and this is definitely the most complicated code in the game so far. But the general idea is that you have an amount of platforms that change, which its maximum is 350. So we can make 350. And you can see that like this is now like changing a lot more, and you can beat the level this way. Like this is definitely like something you can do. You just kind of like run back and forth, and you'll eventually get to the bottom. But it is pretty fast. I'm going to run off the level so that I get back to the top. Just try to get back to the computer. And the other thing you can do is, in addition to the amount of things that are changing, you can change the rate at which they change. So if we said like 2 seconds, now as the things are changing, they last for quite a long time, and you can drop through the level. And this is just a big grid of game objects. And at the interval that is set by the code, I just pick random ones, like literally random ones. Like I think just based on an integer, and then I find in an array of these game objects where that integer like corresponds to, and then I just set its opacity to 0.2 or something like that, and then it's solid, I set false. Because with the solid component, let's take a look at the level 5 code. With each of these grid squares, let's go ahead and look at the grid objects. They all have a solid here, and then if we look for equals false, you can see that I shuffle the grid and all of the things inside of it, and I slice 0 to however many of plats is defined by the code, which I think is 30 at first, but up to 350. And then I set solid false, and then opacity 0.1. And that's what kind of gives this effect of like the thing, the grid going away, or the grid cell going away, and then also allows you to drop through. And we can look at debug mode and like see like all of these like little objects that are on the screen, and they continue to have their areas, but it's not a solid area if it has been picked by the random selection. And then you drop through and you get to the end of the level and you get there. The idea with the beginning and then it's it really wanted this effect of like, you've played through 4 levels and now you hit this 5th level, and it's the same scale you've been at, which is 1:1 camera scale, and then you zoom out and you kind of like see like it's a much more expansive world than it first seemed in the first 4 levels that are kind of like much more zoomed in. And that's just using camera scale in Kaboom. So you can see here, I have this utility that I'm using. I actually have to update this code because it changes a little bit. But it resets the camera first to camera scale 1 and the right position. But then it waits 1.5 seconds. And after waiting those 1.5 seconds, it makes the camera scale half of what it was. So it zooms out by 100%, basically. And then it sets the camera position to be in the center of like the whole kind of like view, which kind of gives this effect of like you dropping into the level, and then you have the camera scale out after 1.5 seconds. And it's just a built-in function with Kaboom Cam Scale. Yeah, that's level 5. Level 6, I would argue, is probably the hardest level in the whole game. Um, I think that if you are a competent JavaScript programmer, levels 2 through 5 and what you have to actually solve there is pretty straightforward. Um, but level 6 is more than just like the programming, because there's 2 computers in the level, and you kind of like are blocked from getting to one computer based on what you configure in the other one. And also, if you've played my game already, you'll notice that this level looks a little bit different in that it has markings X, Y, and Z on the portals, which I'll get to in a little bit. So here's how you beat this level. You have this gravity strip here that when you enter this green zone, like you can't jump high enough to get to these portals up here, but you have this gravity strip that'll like take you upwards, but it doesn't take you upwards fast enough to reach that Z portal. That Z portal is actually your destination, and where you have to get to. So the way that you make this thruster, this gravity strip thrusting you upwards a little bit higher, is you need to get to the computer over here, which you can do by taking the X portal, which it used to be called the magenta portal. And then in this computer, you can set your thrust speed to be up to 100. So if we say thrust speed 100, we can use the Y portal to get back there, and then use whoop. So if you hit, if you set 100 thrust speed, you might go too high up and like exceed the ceiling of the level. So that's one mistake you can make. So let's reset the code, and let's be a little bit more specific with our thrust speed, and let's make it like 90. Thrust speed is 90. Go back through our Y portal and go upwards. And then you can see that the Z portal just kind of takes us to somewhere that we already wanted to go. So these gray like destination portals that X, Y, and Z take you to, the way that they're configured and the way that you can like fix this is you can access this computer down here. But you can only get to this computer if your thrust speed is much lower, like 0. 0 will work. So we can set our thrust speed to 0, and that will make it so that we don't actually go upwards while we're in this zone, and we can move across it to get to this computer. This computer controls where the portals go. And this is a little bit of a puzzle. It's not a really deep one, but you'll notice that the X portal goes to the sun portal, the sun destination, which happens to be this one, because if you take the X portal, you move here. The Y portal goes to the moon location, as you can see in this like object here, the moon location, and the Z portal also takes you to the sun location. So the idea is that you have to set the Z portal to go to the right place. Um, but the question is, what is this one called? It's not sun or moon. And this array right here, the destinations array, is moon, sun, and stars scrambled. So the idea is that you have to set portals Z to stars, and that will set the right destination. You can't set a different destination for portal X. So if you want portal X to go to stars, you get a custom error thrown at you. Some destinations are faded. And that's because this last line right here that says freeze portals X, portals Y. It's just not a way that I wanted you to solve this puzzle, I suppose. One really big lesson that I took from this level as a game developer is accessibility. Because the way that this code used to look, if we go to the live game, which I have not updated yet because it's part of the game jam, you can see that these portals are not, and there's my background music, which I have turned off for this video, but you can see that these portals are not labeled anything. And if we go up the thruster to our thrust speed computer and then set our thrust speed to 0, we can go across to this computer, and you can see that the portals are named magenta, teal, and green instead of X, Y, and Z. And this was a big mistake that I made because this is not colorblind friendly. So if you're building games, that's something that you want to keep in mind is, can your player, who may not be able to tell the difference between the colors in the game, can they go through the game effectively without knowing how to distinguish those colors? And that's a big mistake. The big mistake that I made here, one of the biggest mistakes I made in the game as a whole, was making it so that this had to be understood by knowing what the colors were. So that's why these are now labeled X, Y, and Z. The colors are still there. It'll still make your color, your player color match the color of the portal that it's going through. But it was, yeah, it was a big like, oh yeah, of course, I should totally be thinking about that. And it's important to include accessibility in your games. And I have another lesson in that realm for the next level as well. But yeah, if you set portal Z stars, you can then take the Z portal. But the problem is that I set my thrust speed to 0. So now I have no way of getting back up to the X portal or the Y portal, or definitely not the Z portal. So gotta do this a little bit different way. And I can't really go anywhere anymore, so I have to use my reset. All right, and let's start this over again. So what you have to do is you have to pick a value for your thrust speed that will make it so that you can move across the green strip enough to get to that other computer. I think 5 is a good value because you're still moving up. You can see you're still moving up here, but you can float across quickly enough to get across the green strip without the thrust speed making it so that you go above. And then you can set up this portal here to make sure that portal Z, so portal's object Z key, goes to the string stars, or that destination. And then your thrust speed is still positive, so you still go upwards. It's a little bit slower than you would want. You can't get to the Z portal at this point, but you can get back to the X portal, which means that you can set your thrust speed again. 90 is a good value for this. And then move back to the bottom of the thruster and now have enough speed to get up to your Z portal and port across to that stars destination and beat the level. A lot of the same sort of things I talked about with level 4 came up here with the thrust speed and that like gravitational pull. Stuff with like the max velocity being altered, and I made it so that as your player like moves the portal destination, it's phasing, so that like you can't control it because you're like phasing across the level. But yeah, lots of lessons here in this level, but I'm pretty proud of it, and it's probably where most people that I've heard have gotten stuck, is here in level 6. So before we get back into level 7, I want to turn the background music back on because I haven't talked much about the background music at all. Here's this flag that I use while I'm developing. I don't want to be hearing the drone the whole time, so I have as part of my background music like manager code that like controls which song is playing at any given point. A flag that I can set to true and false that says I should be playing this music or I shouldn't be playing this music. So I don't have to like remove the play calls from the different levels. I can just set this to be true or false. But we're going to turn it back on because in my opinion, level 7 is more of a not really puzzle experience, but a story experience. And that's something that I was planning to kind of get into the whole time I was building. Evidenced by, I think, some of the comments that you read in the code. So looking back at level 2, we go back up here. Let me make sure that this music isn't too loud. You can see that all the code that like you write, there's like comments in it. And I always kind of imagined when I was setting up those code blocks that the comments were coming from someone, right? They weren't just there, but they like were coming from some sort of entity. If we look at level 3's computer, this comment that I gotta jump. This comment that says, "I see you know a bit about this." That could be like the developer. That could be like me talking to you as the player, but it's not. Like I wanted it to be like this unknown entity that's kind of like following you around. If we look at level 4, we see the comment, "This is a fate we cannot escape. Like gravity, it rides everything," which is a Modest Mouse reference. So all throughout the game, I've been kind of like hinting at this thing being there with you. And level 7 is where I wanted to, I think maybe I was just getting a little bit of like disillusion building this game. But I wanted to make something like, I guess meta, like self-referential or breaking the fourth wall a little bit, in that I expand this entity that's in the game with you. One mistake that I made with this level for sure is a lot of people thought that this level was the end of the game. Like this level, like that you're just like floating in space, is just like where you stop. But if you look at the computer, you can't move around in this level. You can only access the computer. And in this computer, there's a lot more comments. Like, where would you like to go, explorer? Yes, go where you like. And there's like in these comments is a little bit of taunting, I would say. You know, like swim with me. Some code you can't change. There's also a reference to the Kajam hashtag, Kajam 2021. And this last comment is actually a hint at what you should be doing for this puzzle. Because with this code, you can go down at a certain speed, right? So if we say it down by 1,000, we start going down a lot faster. We can go to the right, and that starts moving us right. And we could swim across this empty, vast space all we want and go nowhere. And that's kind of the idea. And once again, I was kind of thinking of like, what is the theme of this game jam? It's huge, right? And I wanted my idea of huge to be the vastness of space, the infinity of space. It's as huge as you can get, right? So a lot of people that play tested my game or like tried my game and said it was a really cool game. Did I get to the end of it? Kind of got stuck here because they didn't realize what you have to do, and that is stop moving. So if you hit 0 and stop, you see the first instance of our entity kind of come in, and I reuse the like error throwing from the game in order to like have this entity talk to you. And this entity is Abel. And this is at the point in the game in which he starts to talk to you. It starts to interact with you. And like the dialogue and kind of like the story of the game starts to come. So this puzzle is basically an XY coordinate puzzle. You are somewhere. Me, Abel, the boss of this game, is somewhere else. And you have to figure out how to get to it. So X and Y, left and right. Negative X goes to the left. Positive X goes to the right. So you want to be going right, because currently I'm at 4,000 X, and Abel, the boss, is at 500,000 X. So I want to be going to the right. Um, and then Y, as you increase Y, you're going downwards. If you decrease Y, you're going upwards. And Able is at 478,000 Y. So we want to be going right and down. And that's always how this level works, is it's always just taking whatever position you ended up in when you figured out that you have to stop. And then the boss is 500,000 units to the right of you and down from you. So that's what you want to do here, is you want to swim towards the boss by moving to the right and moving down. And you can go, I think in the deployed version right now, it is 20,000 is your max speed, but I changed that to 10,000 just because I think it has a bit of a cool effect. And the way that the dialogue starts to show up here, so you can see that there's like dialogue being shown, is I am reading how close you are to the boss, and every time you hit a certain threshold, a new dialogue will show up. And I did this so that you knew that you were getting closer, right? And to just kind of like add to the sense of the game. The other thing you can see is that there's a game object following your game object right behind you. It's faded out, but you can see it pretty well. And that is this entity, this thing that is with you. And I guess the idea, that the story behind Abel, the boss, is that he used to be like you a long time ago, kind of like going through this like world with computers and I'll kind of like restart that. But like you he wasn't able to escape, right? Like he's been stuck in this like thing, like this vastness of space and these levels with the programming, and he's just like, you know, went crazy. He just like changed over time, and that's kind of the idea. And then now he has somebody with him, you as the player, kind of trapped in this prison with him. And you're making progress to escape it, but he doesn't want that. He doesn't want to be alone. So yeah, that's like the general idea. It's up to your interpretation, but that's kind of like what was going through my mind when I was like kind of building the story and the dialogue of the game. So yeah, so we'll travel across space again, and once again, like I'm just like recording your distance, and you are actually in this like extremely big like world, and you are actually moving. It's not like you are actually being positioned. If we were to scale the camera out, you are actually like flying very quickly through the game world. But I made it so that because you're phasing, like you don't die when you hit a certain Y value, so there's no like respawning or anything like that. And yeah, that was kind of like the idea of like what I was going for, of just like you swimming in this space. I made it a little bit hard to figure out what you need to do here for sure. Another thing to notice is like if you look here in the DOM tree, all of these like dialogue boxes are like the coding boxes in that they're not part of the game. They're actually layered on top of the game canvas as pre-elements, as like DOM elements with text. So once you get to a certain distance, you see the flash of Abel and you know the thing that you are about to fight, and then you get to the boss door, and move on to level 8. So I knew at the point in which level 7 was done that I needed to wrap up, because I think I worked on level 7 deep into the early morning hours on Saturday, and I had a deadline for the gym on Monday night. So I had to figure out what I was going to do to like finish the game. And like any good game, I was thinking I gotta do a boss battle. Like I gotta have a final boss of my game. And that has to be Abel, the thing that kind of like taunts you and follows you in level 7. And it took me a lot of thought, a lot of discussion with my wife, who helped me a lot with this game and play tested it all the way through. And I came up with this idea of, you know, a puzzle boss, right? Um, I am a programming instructor. I do web development as like my main expertise, and there's this thing called unit testing. If you've never heard of it, something like Mocha or Jest, in that like you have like your code that is tested with other code, and then you get like a pass fail on it. And I thought it would be kind of cool if like the final boss was like a unit test spec. And that's kind of like where it started. And then I thought of like there needs to be like 3 tests. So let's take a look at the boss and I can kind of expand on this idea. So here's the beginning of level 8. Something that may not show up well in the recording here, but you can see Abel a little bit behind you as you enter this level. Like he's already kind of waiting for you, but it's really subtle. Like you kind of have to like notice that, just to kind of give it like a creepy vibe. This is also the only level where at the beginning the camera is actually following your position. Every other level has a static camera position. Well, I guess level 7 doesn't because like it's moving with you, but this is actually like kind of like following you along. And I did that to give you a sense of like you don't know how big the place you're inside of is, right? Because the camera is like centered on you, so you don't know how far out to the sides and above and below you this level actually is. It's kind of like gives it a mysterious vibe. And then you get to this really long platform and then a very simple puzzle. If you've ever done any programming, you know what a Boolean is, right? And this is saying that there is no escape. And I wanted it to be like kind of a defiant moment of like, no, there is escape, right? No escape, false. And as soon as you put in that right answer, it zooms out and shows you that you're in this kind of like elevator. That's what it's called in my code, is an elevator. And then it comes up and then there's Abel, right? Like you're trying to escape, you're trying to get out, and he shows you his motive. He doesn't want to be left here by himself. And then here's the unit testing boss. For a while, it's like you kind of have to observe this this level for a bit, and kind of get a sense of what's happening. But there are a couple of things that I did to kind of clue you into what you're supposed to do. In that, like if you jump on one of these platforms, for example, you see that it turns red, and then like you get a number 1 at the end. And then after each of the phases, it just kind of like repeats in a cycle. After each of the phases, Abel shows up to like see your results, and then he tells you, you know, wrong, wrong, wrong. And then this dialogue shows up, your time with me equals infinity, or prison sentence equals infinity, which is actually a hint for the next level, or the ending level. So yeah, and the other thing here is with the black hole, where it's like sucking in the stars, and you can see like the as they fall, they get sucked into the black hole, and then your thing gets larger. So the idea is that like each of these computers controls what you need to do for each of these phases, and you just need to get the right number. And the amount of stars that show up in the black hole phase, the amount of stars that show up at the beginning phase with the bar, those are random, and then there's always 7 platforms at the end. So let's do the first phase first. Here you need to make it so that this white bar that's across the screen here, it's filtering the stars that are falling through it, and you need to get to the red stars in order to count the right number. So you need to set the bar color to red, because when a bar touches a star and a bar color is equal to the star color, it'll destroy that star. The second one, the black hole kind of like moves around. So I'll wait around until it comes back again. And it's something I don't love about this boss fight, is that like you do kind of get stuck in these phases for a little bit, and it's maybe a little bit of a boring experience to have to wait for things to cycle through. But you can see like here with the bar catching the stars, that your number is going up correctly every time it like meshes a red star. And we'll see that we got the correct answer for that one. Here with the black hole, you get to choose for each second of this phase where the black hole belongs. And the way that I found best to like solve this one is to take which second you're at and move it across XYs, which is what this is, XY. So we can say that it should move like 300 units across, and then setting the Y to like somewhere in the middle, which is like 600-ish, maybe 400. Notice how we got the green for the first phase, right? So now I just updated that black hole code, and what that should do is it should make it so that the black hole itself moves in accordance to the code that was written. So first second, third second, fourth second, and you can see that it like kind of like slowly moves across, and it ends up collecting all the stars for that phase. This last one is that like you might be able to beat this, but it's super hard without all the platforms are basically stacked on top of each other. and we can update this code. Let's look at able testing first. Okay, so we got the right thing in phase 1, the right thing in phase 2, but our phase 3 is wrong. Once you get the right things in phase 1 and phase 2, they basically work the whole time, and then you have time to figure out the plat 1. And you don't have to do it in order either, by the way. But this is what I like to do for this level, is I like to make the xi, so the platform itself, times 250. And what that will do, it will stagger the platforms so that they're kind of like more stepwise, like this, staggered, offset from each other. So you can like move to the side of one and jump on top. And then there's our 3 correct numbers, 28, 62, 7. For it's usually random for the first 2. But if you get all 3, you can see that you've defeated the boss. I wanted to have it like kind of like an understated sort of like thing. Oh, that looks like a bug. It looks like that didn't work out well. So we can go ahead and maybe fix that bug. But yeah, the code for this boss battle is pretty beastly. I spent all of Sunday and then a lot of Monday working on this boss battle. That's a pretty big file. It's an 800 line file exactly right now. And that's with after some tweaks and cleanup that I've done since the end of the jam, but I have not deployed. And yeah, there's just like a lot of timers. We have 3 computers. They all have their own effects. There's a lot of like interesting stuff going on here, but it looks like I screwed up my win state. So I'll show you something that was like useful to me while coding and kind of like a game development tip in order for me to test what's going on here. So it looks like my elevator itself is not like moving up the way that I expected to. So I have this like elevator that the camera position is kind of supposed to move down. And I think that's because this is moving way too fast. So maybe if I try doing this. Now, this code that I'm testing and trying to fix only applies when the level is beaten. So in order for me to test this, I would have to beat the boss again, which takes a lot of effort, honestly. Like you have to go to each of the computers, you have to write the right code, you have to wait. So while I was testing this, especially when I was getting to the win level, I had a couple mechanisms in my code that let me do this a little bit faster. First of all, I could choose where my boss starts. So if we look at boss battle phase 1 here, this is where my boss begins, this start boss. What I can do is I can say, let's start on boss battle phase 4. Phase 4 being the end where he's checking all the answers. The other thing I can do is I can make it so that all the answers are just like checked as true if I want. Just by so I have, as Abel goes through in phase 4, here's boss battle phase 4. It goes ahead and checks each of the answers to see if the determined answer is the true answer of that phase. Basically, if you have collected all the stars or jumped on all the platforms, does that match the number that is expected? But something that I can do here in control of this code while I develop is just say return true. So every answer is just by default, it's going to be true. And this makes it so that if I'm debugging like the end of this level, you know, I can go here, and there are ways that I can like make it so that I spawn in the right position here. Maybe that's one more thing that I can show you, is I can temporarily change the player's spawn point to be way more to the right. So let's try like 700, so that it changes where I actually spawn, so I don't have to like run across the level to get to the beginning computer. So that's not quite far enough. Let's try 1200. Yeah, that's getting closer. I still have to walk a little bit. And if I'm going to be testing this over and over, I probably, yeah. So that's pretty close. Like, I could get it even closer. And then this will be false, which once again, like I could program in a shortcut so that it already has the right thing. I can make it so that like the timers on this stuff are much like quicker, so that I can just get to the boss and like test it the way that I want to. So now we skip right to phase 4. You can see all the answers, even though they're 0 are true. And then we win the boss battle. And then let's see what's happening here. Okay, that's moving way too slow now. Yeah, that's moving way too slow. Also, the camera position was all out of whack at that point. So we got to figure out what's going on there. This maybe is not something I'm going to do as footage, but let's see if I can figure it out quickly. Um, so yeah, it's this looping here. I need that to be a little bit faster, a little bit faster. So that was doing it at 0.05. The reason this is happening is because I recently updated all these timers to be wait and loop instead of set interval and set timeout, just to make it more kaboomified. Right, so we're entering the boss level again. Here he is. Little scream that I added in. There's like a little scream sound effect to like kind of like enhance the moment a little bit. And if this doesn't work this time, I'm just gonna move on and fix this off camera. But yeah, something weird is happening there. Oh well. And then we get to our win level, which is going to be my last. The final level of the game, technically not much of a level, more of like a story end, is level 9. And the idea with this level is you've gotten to the top of your of the elevator and you've beaten the boss, but he's still there. He's like trapped in this world with you, and he's taunting you with that. You're also trapped here because you are small, you are hopeless, you are afraid. There is no way to escape this. You are stuck here with me forever, no matter what you try to do. And yeah, I have solid walls on the ends of this platform, but you get like a little computer here with a single variable and a little poem that I wrote. And I thought a lot of people also got stuck here. A lot of people are like, okay, I think I beat the game, I beat the boss, but like nothing happens after that point. And you can try any number that you want here, like 3,000. And no matter what you put in, even if you generate an error, it just like kind of like shows in the screen like this, and just like more taunting, right? I just have a big list of strings that he taunts you with. If we go to the win level code, we can see that those strings are weak, puny, small, failure, hopeless, alone, die. And that's what you'll get randomly as you fail to find the answer to this level. This is the reason why during the boss he taunts you with the infinity number, and like, your time with me equals infinity, your prison sentence is infinity. That's supposed to be a hint for this last sequence here. Infinity is a number in JavaScript. If we go over to the console, we can see that infinity is indeed greater than the number 5, right? Infinity is greater than any number in JavaScript, and negative infinity is indeed less than any other number in JavaScript, including 0 or negative 1 million or something like that. So yeah, the answer to this level is infinity, and this is once again me trying to introduce the theme of the game, or the theme of the jam of like huge, right? And that like you are in this level at the end of the game as the final thing you do in my game Vast, becoming yourself vast or huge, infinitely big, which I think it's a satisfying end. In the deployed jam version, I broke the credit screen, but this is what it's actually supposed to look like when you win. So if you go here and you pick infinity, which is the biggest number that you could pick for your size, you get this little sequence where you grow large and then fade to white, and that's the end of the game, which is a lot more obvious when the credits show up. I put the little kaboom beam in my level 7 code in order to create this GIF. So instead of the stars showing up, it's these beams. And it says here, this is the happiest I've ever been. And then my credit screen, and then this is like the credit screen from the title card, but it has like a little message on top to make it a little bit different, to say congratulations and thank you for playing. And yeah, that's my game. I built this game in 5 days. It was a lot of work. I basically was obsessed with building it during that time. But I'm really, it's probably my first completed game, and I'm quite proud of it. And if you have any questions about it, you can find me on Discord. I'm in the Replit Discord. I'm in the Kaboom Game Library Discord. You can also feel free to reach out to me here on YouTube if you want some tips on building games with Kaboom or want to learn anything else about my code. And also, my code is publicly available. It's open source game right now, and you can find it at my GitHub, which is 00.js/vast. And I'll put that in the description. But you can find all the code that I've been working on currently, as of today, November 10th, on the post jam branch, which is all the updates I've been making since the jam ended. But yeah, thank you for watching. I hope you enjoyed my game, and I'll talk to you some other time.